Why are insects drawn to light? A perennial question gets a new answer. A new study offers an alternative to earlier explanations for why moths and other bugs are attracted to artificial sources of illumination. Moths and other insects are drawn to lights at night as reliably as planets orbit stars. Entomologists have long exploited this fact by setting out light traps whenever they want to collect insects. Poets have reached for the image of a moth drawn to flame to signify self-destructive behavior in works ranging from The Merchant of Venice to the Hindu epic the Bhagavad Gita. Ecologists, more recently, have begun to worry that the lure of artificial lights across Earth's nighttime surface may partially explain why insects are in global decline. But, despite all this, scientists still didn't know why. A lot of entomologists get asked this all the time. Evelyn Owens, a biologist at Harvard, said. One prevailing theory, popular but flawed, she said, is that flying insects confuse our porch lights for the moon or another celestial body, and their sense of navigation gets scrambled. Another idea is that lights at night look like glimpses of daylight through a thicket of vegetation, prompting insects to try to escape by making a beeline toward what they think is open space. Now, though, a new answer has the entomology world abuzz. A team led by biologists Samuel Fabian at Imperial College London and Yash Sandhi at Florida International University argue that when many insects see a bright light at night, they believe they've found the direction of the sky and attempt to orient themselves along an up and down axis. That instinct prompts them to roll their backs toward the light, mistakenly in cases when the source of illumination is on the ground or mounted horizontally, causing them to go into endless banking turns like a tiny airplane or to crash land. The findings were published in a paper that was uploaded to the bioRxiv server but has yet to be peer-reviewed. In the daytime, entomologists knew such directional instincts help flying insects stay level by keeping their backs pointed toward sunlight even during aerial maneuvers. The new analysis, though, shows that lights at night appear to hijack this instinct. To arrive at this conclusion, the scientists took high-speed, low-light video of dragonflies, butterflies and moths flying around light bulbs both in the lab and in the cloud forests of Costa Rica. Sometimes the insects would start making circular loops like an orbiting moon. Other times the insects would pass the bulbs, then tilt upward into a stall. Or they would fly above the bulbs, then flip themselves upside down and nosedive toward the ground. In each case, though, the slowed down footage showed that the insects always tried to keep their backs aimed toward the light, a result the team confirmed by gluing little motion trackers on the insects. In turn, the team found through computerized flight simulations that those inadvertent roll maneuvers could explain the bugs' looping, trapped flight trajectories. This is the best argument so far for what explains this behavior, said Tyson Hedrick, an expert in the aerodynamics of insect flight at the University of North Carolina, who said he had previously favored the idea that lights interfere with the celestial navigation of insects. Continue reading the main story. It's one of these things that we all sort of think we know about nature, he said, and it's getting overturned. The new study also offers a hint of how to mitigate the effect, which can kill insects in ways that are poetic, burning up in flame, or more sinister, like getting trapped in the web of a spider that has learned artificial lights provide prey. Some insects also simply run out of calories by flying in circles. The research team found that insects seem least affected when they fly under lights that are projected straight down, as opposed to lights that shine upward or that have been mounted horizontally. This finding dovetails with long-standing advice from researchers to limit light pollution by using downward-pointing light fixtures that illuminate only the nearby ground. Aside from beckoning insects, lights can also interfere with the development of caterpillars, cause fireflies to stop flashing, and shrink the habitat of shire nocturnal species that venture out only in pure darkness. Dr. Owens said. The most effective way of solving this problem is always going to be turning off the lights, she said. Light pollution is a driver of insect declines. Abstract. Insects around the world are rapidly declining. Concerns over what this loss means for food security and ecological communities have compelled a growing number of researchers to search for the key drivers behind the declines. Habitat loss, pesticide use, invasive species, and climate change all have likely played a role, but we posit here that artificial light at night, Antlion, is another important but often overlooked bringer of the insect apocalypse. We first discuss the history and extent of Antlion, and then present evidence that Antlion has led to insect declines through its interference with the development, movement, foraging, and reproductive success of diverse insect species, as well as its positive effect on insectivore predation. We conclude with a discussion of how artificial lights can be tuned to reduce their impact on vulnerable populations. Antlion is unique among anthropogenic habitat disturbances in that it is fairly easy to ameliorate and leaves behind no residual effects. Greater recognition of the ways in which Antlion affects insects can help conservationists reduce or eliminate one of the major drivers of insect declines. Introduction. Over the last 2 decades, researchers have uncovered steep declines in insect diversity and biomass. Durzo et al. 2014. Potts et al. 2010. Across geographically distinct areas including Germany. Hallman et al. 2017. The Netherlands. Van Langeveld et al. 2018. Van Streen et al. 20,193, Sweden, Franz N. and Johannesson, 2007, The British Isles, Pony et al., 2019, Shortle et al., 2009, Wilson et al., 2018, Puerto Rico, Lister and Garcia, 2018, and Costa Rica, Jansen and Hallwicks, 2019. This alleged insect apocalypse, Jarvis 2018, has generated an appropriate amount of public concern. Insects are a critical component of all terrestrial and freshwater food webs. Baxter et al. 2005, Van Veen et al. 2006, and provide important ecosystem services. Showalter et al. 2018. Their absence would have devastating consequences for life on this planet. If insect decline is indeed a global phenomenon, see Wagner, 2019, the question then becomes, what is the problem, and how can we best address it? One recent review of insect decline has sought to identify the main causes by ranking potential drivers in order of their frequency of mention within relevant literature. Sanchez Bayo and Wykes, 2019. The authors found, as indeed have we, that habitat loss, chemical pollution, especially pesticide use, invasive species, and climate change are the most well-described threats to insect persistence. However, we do not agree that relative degree of scientific consideration reflects importance in this case. Instead, we posit that diurnal bias, a preference among ecologists for studying daytime phenomena, Gaston, 2019, has led insect conservationists to overlook another widespread habitat disturbance, pollutant, and method of insect control: artificial light at night. Antlion. Although discrete sources of anthropogenic light have been used to kill insects since circa 2014, see Beavis 223, the modern phenomenon of ecological light pollution began in earnest with the invention of the arc lamp in the early 123s. Dillon and Dillon, 212. Saunders, 2012. Soon after, dedicated light traps were adopted as a common method of pest control. U.S. Patent 2019, and are indeed still used for this purpose today. Johansson et al. 2011. Pawson et al. 2009. Shimoda and Honda 2013. Around the 1950s, light traps became popular among entomologists for use in surveying insect biodiversity. Leather 2015. More recently, as lighting technology has advanced and the cost per unit of brightness declined, both the intensity and quantity of artificial light installations have increased worldwide. Kiba, 2018. Kiba et al. 20,123. Tsao et al. 2010. Modern light pollution is no longer confined to urban centers but radiates outwards through the atmosphere and along road networks that run into or around otherwise pristine areas. Gaston et al. 2015. Gaston and Holt 2018. Et al. Since 1992, levels of light pollution have doubled in high biodiversity areas and are likely to continue to rise. Cohn et al. 2018. Kiba et al. 2017. By 2014, over 23% of the land surface of the planet experienced artificially elevated levels of night sky brightness. Falchi et al. 2016. By comparison, agricultural crops cover approximately 12%. FAO 2012. Insect conservationists now frequently lament, as do we, the dearth of insects to be found swarming around artificial lights. E.g., Jansen and Hulwix 2019, yet rarely consider that the lights themselves may be an issue. Artificial light at night is a potent evolutionary trap. Schleepfer et al. 2002. Altermat and Ebert 2016. Hopkins et al. Most anthropogenic disturbances have natural analogues. The climate has warmed before, habitats have fragmented, species have invaded new ranges, and new pesticides, also known as plant defenses, have been developed. Yet for all of evolutionary time, the daily cycle of light and dark, the lunar cycle, and the annual cycle of the seasons have all remained constant. Until now, Altermat and Ebert 2016, insects have had no cause to evolve any relevant adaptations to Ellen, and so some species retreat from streetlights. Farnworth et al. 2018, while others for unclear reasons perch beneath them.